Hello everyone, by request I am making a video for a sample problem from section 7.8. Also by request I've tried to choose one that's fairly complicated looking and not just a simple one, so hopefully understanding how to do these complicated looking kind of problems can help you understand not only the simple ones but the harder ones as well. So this is a problem from section 7.8 which has to do with variation, both inverse variation, direct variation, and so forth. The problem is that t, the variable t, varies jointly as p and the square of r and inversely as z. Then they give us some information right here about values for t, p, r, and z, and then they ask us a question, find t when p, r, and z have certain kind of values. All of these problems generally work around the same way. The first thing that you always have to do is take this kind of preliminary information about variation and write a variation equation. So we'll start with that. And so I'm going to jump right into the equation editor. And I'll start with the t variable, which varies jointly. So as soon as you see that it varies, this always means that it's some constant multiple of the things that are going to follow. Now I'm also seeing that I have inversely and a joint variation, so that means I'm going to have a fraction. I'm going to have some things that are straight across and some things that are a reciprocal kind of relationship. So since I have both, I'm going to set myself up with a little fraction bar so that the things that vary directly I can put on the top. I'm going to put in k as the constant for the variation. That's not a variable, it's just a constant, and we'll actually use the rest of the information in this problem to solve for k later. So it varies jointly with p, so I have k times p, and then the square of r. So I'm going to have to put in an r squared. I'll use my little squaring tool and put in the r and the second power. So this top says that it varies jointly. It varies, that's the k, with p, that's the p, and then with the square of r gives me the r squared. And then inversely as z means that the z is going to go in the reciprocal or in the denominator of the fraction. So this is the expression the equation that states the equivalent of what is verbally described here as the variation equation. Okay, so now we substitute the given values, which is in this second part of the question, t equals 15 when p equals 2, r equals 1, and z equals 6. We're going to substitute all four of these numbers in for the letters over here in order to solve for the value of that constant k. So let's do that here. I'm going to plug in for the t, I'm going to plug in 15. I'm going to put my fraction in. K is the thing we're trying to solve for. I don't know what that is. The value of p is given to be 2. I'm going to just use a parentheses to emphasize that the 2 is kind of by itself. And then I have a value of 1, which is then going to be squared. Now we could take shortcuts and know that 1 squared is equal to 1, but I'm just going to write this as the squared expression. And then the value of z that's given to us is z equals 6. Okay, so now we're going to simplify, solve for k, little k. So we have 15 on the left-hand side. 1 squared is 1, so on the numerator I have 2k over 6. And of course you could cancel the 2 with the k and the 6 to make it just k over 3. So I'm actually going to do that all in one step here just to save myself a little bit of time on the video. So you have k over 3. So now in order to solve for k, multiply both sides by 3 to clear the denominator, and we end up with the value of k of 45 on the left hand side. Again, it's 15 times 3 equals k over 3 times 3. Of course the 3's cancel over here, or just 45 is equal to k. Okay, so the value of k is 45. And so now we're going to plug this value of k back into our original expression, which had all these other letters in it. Okay, so plug back in to our variation equation to get the formula which is really all the same stuff as up here. I'm just going to use the copy and paste feature. And then I'll go in and I'll edit the k out and I'll put the 45 in. So that's our formula that relates t with p, r, and z. Okay, so now we have one more step to go in this particular problem, and that is we go up here, now we answer the question. Find t when p is equal to 3, r is equal to 4, and z is equal to 10. So we're going to plug in p equals 3, r equals 4, z equals 10 into this equation and solve for t. So we'll start with our t, which is what we're trying to solve for. We'll do our fraction bar. We'll put our 45 in, which was the value of k. Now I'm going to plug in the value of p, which was 2. So the 45 gets multiplied by 2. The value of p should be 3. Find t when p equals 3, r equals 4. So I need to plug in a 4 for r, remembering that it gets squared. So let's do times. We'll put in our little subscript, a 4 with the squared option. And then in the denominator, I'm going to put the value of z, which is 10. And then we'll just simplify this expression in order to solve for t. So again, we have t equals. Start with the fraction. On the top, we have 45 times 3 times 16. And in the bottom, we have 10. And if you solve this, I'm just going to do it inside the same equation box. So let's see, 45 times 3 times 16 divided by 10. 45 divided by 5 would be 9. 16 divided by 2 would be 8. So you have 9 times 8 is 72. Times 3 is 216. And if I haven't made any mistake, that's the end of this particular problem. So let's just review really quickly. We were given some kind of a statement about variation, which was the first part of this problem. That allowed us to write the variation expression with a k. We were given some values for all 4 of the variables, which allow us to solve for k. Then once we solve for k, we plug that value back in for k to give us a formula, and then we can answer the question which is presented right at the end by substituting the values in and doing some arithmetic. Alright, well that's it for this video. Hope this has been useful, and talk to you again soon.